All right, folks. While people come in, we'll just start with a short video, like a 2-minute video, and then we'll get started with the talk.
The Xbox Live service powers a lot of the social experiences on the Xbox console. Things like competing with other players, playing with other players in the same game, either cooperatively or competitively, and then also tracking your progress. We hope that by providing these social features or these challenges features or things that kind of go beyond the gameplay, that we're able to give you a much better, more enjoyable experience when you're on our platform. All of our services use Azure Tables for their base layer of figuring out where a storage account is located. So at the end of the day, you use an Azure storage account for your blob and table storage, but we use many of those for each service. And we do that because we want to be able to get more of that elastic capacity out of Azure, and also because we don't want to pull all of our data in one place for things like disaster recovery purposes. So every service in Xbox Live uses a common platform based on Azure Tables to figure out where each user's data is stored. Xbox, when we ship a new feature, millions of people use that feature almost instantaneously. And that's a significant amount of load that we've spent the last 10 or 12 years trying to figure out how to handle and scale for. And as we moved to Azure Storage, we were concerned that, could this partner service do the same thing that we were already doing internally? And it was fantastic that it could actually do that. We've never seen an issue where we deployed a new feature and Azure was the bottleneck that caused us to not have that feature work. As we look to the future, we want to be able to get things done faster and try things out more. And we're going to make mistakes, but we're also going to do some really great stuff. And the faster that we can iterate on these things, the faster and more likely we are to make our customers happy. We want Xbox to always feel like the best place to play games. And that doesn't just mean that we have the best games, but that also those games are more fun on our platform. The more and more data that we can push through the system, and the more data we can retain and massage and process, the easier it is for us to light up those experiences. And that's really something that Azure helps us do. We don't have to think about how many more servers we have to buy to do this, or how many more hard drives do we have to buy to store all this stuff. We can just know that almost infinite capacity will be there, and we can build almost anything that we imagine to enable those experiences.
So this is the story of Xbox. And the Xbox Live service in particular. They took a huge bet on Azure a few years ago when building the Xbox One service, and in particular on Azure Storage. Today, you can't fire up an Xbox One without using Azure Storage in its many different abstractions, whether it's looking at your friends list, your achievements, your activity feed, whether it's pulling up a game and loading a saved game, whether it's watching, recording game clips and, encoding them through media services and sharing them out. All of these things use Azure, different parts of Azure, and they use Azure Storage. This is just some of the features that are using blobs and tables in particular from the Xbox. But this is also the story of how Microsoft bets its business on Azure. Right? If you look at pretty much any of our major services today, all the persistent data there is stored in Azure Storage, whether it's OneDrive, OneDrive for Business, Office 365 and SharePoint Online, whether it's Skype. All of these services in some form or another persist data, object data into blob storage. They persist structured data into table storage, and they use queues in conjunction with their other Azure services. So we've kind of spent a lot of time learning these lessons internally, and having that credibility to come to you as customers and say, please bet your business on us. We'll talk a little bit about how all of these services have been built and how you can do the same things. So this talk, I'm going to kind of split it into 3 parts. The first part of it will be an overview. We'll talk about the different data abstractions, what Azure Storage is and what its capabilities are. And the second part, we'll talk about DevOps, how you can monitor and run your service once you have, and how you can monitor the storage pieces, which are critical parts of most infrastructure. And then in the third part, we'll talk about some design patterns and talk about new features that we've added to Azure Storage this year. Now, whether you're a developer, I hope you walk away from this session saying, hey, it's very easy to get started with Visual Studio, with Azure Storage, and start coding. If you're an IT professional, I hope you walk away with an understanding of how Azure Storage is the underpinnings of all your IaaS VM infrastructure, and kind of get a sense of how that plays into how you build out your infrastructure on Azure, as well as then run and monitor it. So just as a quick level set, how many of you today are using are coding against Azure Storage? A few of you. How many of you are using Azure Infrastructure as a Service VMs and using disks and data disks? Okay, more of you. Great. So we'll kind of use that as a guide, and we'll talk about the different pieces of Azure Storage. So let's start first with this picture. A big part of how we support our large-scale Microsoft Online services is our global reach. We are, much more than 1 million servers today. We have more regions around the world than AWS and Google combined. Really, we are kind of continuing to grow as well. There are new regions announced. India is our newest region, and we continue to work on, adding other regions. Azure Storage is in every single one of these regions. It's a foundational building block of Azure. Along with the compute and networking services, it's the service that every other service inside Azure builds on. So every region that you see Azure available in, the Azure Storage set of services will also be available to you. In terms of scale, our service itself, we talk about Azure being a hyperscale service. The metrics that matter for us, we have more than 50 trillion objects in blob, table, and queue storage. And this is fairly warm storage. We do 6 million transactions per second average across our storage system around the world. So it's a massive system. It's growing exponentially, has been for the last 6 years. And it's really something that gives you the ability to have that hyperscale reach. The other thing that we talk about is the fact that storage and Azure in general is built to be open from the ground up. What this means is you have a REST API, and you can talk to our platform from practically any programming language. We also produce client libraries in many of these languages. Of course, we have the best support for .NET and Universal Apps, but we also have Java libraries. We have C++, Node.js, PHP, Ruby, Python. And we're also looking at the mobile space. We have an Android library, we have a Xamarin client library, and we are working on an iOS client library that's coming soon. So whether you're programming in the enterprise on .NET or Java on Windows or Linux, or whether you're looking at programming for the mobile devices and the huge amounts of data that mobile devices and IoT devices generate, we want to make sure Azure Storage is a place that you can program to easily and efficiently and run your storage workloads anywhere. The last piece of this puzzle is sort of the hybrid piece, right? Azure, from an infrastructure perspective, Azure Storage is the backing store for Azure Backup and Azure Site Recovery. So you can use it to back up your VMs or back up your on-premise workloads to the cloud, have the cloud serve as a disaster recovery site. You can also have Store Simple, which is our enterprise tiered storage offering where you can have an on-prem device with a certain amount of storage and then have an essentially infinite pool of storage in the cloud that your older data gets securely moved to. And now with the announcement of Azure Stack, we have things going the other way. We have an Azure consistent API. The same REST API and the same client APIs, client libraries, will work against blobs and tables on your on-premises Azure Stack. So if you're coding to your on-premises application or the Azure cloud, you'll be able to use exactly the same code. There won't be any difference whatsoever. In fact, we're not producing new client libraries for Azure Stack because it's exactly 1:1 API consistent. So that's sort of the kind of a quick overview of what the characteristics of storage are. We offer a number of different data abstractions on top of Azure Storage, from object storage, which we call blobs and files, to NoSQL storage, which we call tables, and reliable queues. So let's start going through each of these, and we're going to kind of interplay the slide deck with a bunch of demos, kind of showing you how you can code against this or how you can deploy these or monitor these things. So let's start with blobs. Blobs, and for each of these abstractions, I have sort of the one-line takeaway for you to remember. And kind of if you walk away with just that, you can kind of come back into the documentation and go, that's what I need. That's what I'm going to go look for. So blobs are our object storage, right? It's where you store files, essentially. So The canonical usage is for any kind of data in the cloud, any kind of data sharing, big data analytics, backups, and the like. There are two kinds of blobs. There are block blobs, which are optimized for sequential file I/O, and they're typically what you would use. They're the most cost-efficient storage on top of Azure storage, and most file storage options, that's going to be what you go and use. Page blobs are kind of for specialized reasons. They're basically optimized for random writes. So they're sparse files. You can allocate up to a terabyte, and you get charged for only the bytes you read and write. They have to be 512 byte aligned. But the advantage is you get much better random read and write performance. This is actually used as the thing that your data disk and your disks in your Azure IaaS VMs are backed by page blobs. So we use it heavily internally, and we expose the same REST API that our VMs talk to in case customers have needs for that as well. So let's switch over to the demo machine here and start looking at how we can get a blob sample going. So I have Visual Studio here. I have installed the Azure SDK. And I'm going to make sure there's something called the Azure Storage Emulator, which comes with the SDK. I'm going to make sure it's started. And it says, OK, I've gone ahead and started it. And I'm going to start with, canonical new project. So with the SDK, in your templates comes a set of quick start samples under cloud. And under data services, you have quick starts for blob storage, table storage, and queue storage. So let's choose blob storage and get started on that. So that's going to go ahead and bring up a sample for me. If I look at that sample here, it has a program to CS and an app config. I'm just going to start and build this, right? The first thing it's going to do is resolve all my NuGet package references, and then we'll see something start up. Now this sample runs two things, block blobs and page blob samples. We notice, and we'll talk about what these concepts of containers and things are, but essentially I was able to get up and running in just a minute or so. The other thing I want to point out is this thing, right? It's basically running on localhost against something called dev store account 1. That's our Azure Storage Emulator. We provide a dev tool with Azure Storage and with the SDK that allows you to do all your storage code development without hitting the cloud. So you don't have to waste transactions or deal with the latency and things like that. You're just messing around, trying to get a prototype going. You can basically do that. Okay? So let's go ahead and stop that. So the first thing I want to start doing now, I want to start kind of modifying this sample. The first thing I'm going to do is, and here you see the use development storage equals true, which is what's telling it to go against the local host. So I'm going to go grab my account string. I have a bunch of things here. Let me grab the connection string, and I'm going to paste that in here. All right. So what we're doing here now is changing to an account name that's in Azure Storage. The account name is demos15. I have an account key that I can get from the portal, and we'll look at that later. And the other thing here is the default endpoint protocol, which is HTTPS. Now, typically, you want it to be HTTPS, but the only time you'll change this to HTTP is if you're doing debugging or doing development when you want to look at fiddler traces and things like that without installing certs and whatnot on your dev box. Okay? So let's go ahead and run that again. All we did was change that account sample. And now you'll see that I'm running against the cloud. Right? So I've just gone up and done the exact same storage transaction against this demos15 and .blob.core.windows.net because I'm using the blob endpoint, if you will. All right? So let's take a look at the code. All right. So what this code does is, kind of walks through a couple of block blob operations, a couple of page blob operations. The page blobs operations are pretty similar, so let's just jump into block blobs and look at what they do. First thing I'm doing is I'm working with this hello world.png file that's just in my folder. That's what I'm going to try and upload. And then I have this object hierarchy that I'm creating. The first thing is this cloud storage account object. And that essentially represents a storage account. An account is your unit of scale in Azure Storage. It's what we provide scalability targets against. So for example, you can store 500 terabytes of data in an account, and then you can add more accounts as needed. So you create an account object. You then create a blob object, right? So you're creating a blob client, essentially. And that's just saying you want to work with blobs. And then you create a container. A container is like a folder in Azure Storage, right? Essentially, it's a unit of isolation. You can set ACLs on that container. You can drop that container to quickly delete all the files under that container. So think of it as a single directory structure, the top-level directory structure. So far, these are all offline operations. This operation is the first time the create if not exist async that I'm talking to the Azure Storage account and actually making a call over the web. All of our APIs in our client library have both async versions and sync versions. We strongly recommend using the async version, of course. And with .NET especially, it's pretty easy to have code that looks pretty linear but is all asynchronous. And then we've got this container object now. And on the container object, we create a block blob. So we were talking about block blobs. So you get a reference. And then we upload from files. So this is the thing that's actually doing the upload, right? We have taken our image and uploaded it. A single API call to just upload files. A single API call to kind of list blobs. So you can just call list blobs and get a IEnumerable that walks you through the blobs. And you also have sort of download and then delete. So let me start walking you through some of these this code and start making modifications to it. The first thing I'm going to do is, comment out the delete because I want the blob to live there. And the other thing I'm going to do, these samples, by the way, are available in the SDK, so you can, right now or offline, follow along and do the same things. And I'm going to unset this thing that said container.setPermissionsAsync. Remember, I said containers are resource isolation points. And I'm going to change the container from private to public access. Right? So I'm going to make sure that container is now visible. So I'm going to run this code again. And I've commented out the delete, so it shouldn't delete the container. And I'm going to go ahead and go to the URI of that hello world.png. Right? So I can get to it. I've marked that container public. I can just browse to it. Now, if the container were not public, and I was trying to look at this while I was debugging it. Let me go ahead and show you that. We have the Server Explorer. Again, with the Azure SDK, you get a little Azure Tools piece of it. And you can browse and explore all the different services. So let's look at the storage piece. It's, again, talking to my Microsoft account that I've put in already and fetching all the storage accounts that I have under my subscription. The one we're interested in is Demos 15. And let's open up blobs. I see that I have that container, demo container block blob. And if I open that up, I have the hello world.png. Right? So I can browse and kind of do simple operations when I'm developing against Azure Storage, just built in with Visual Studio. No need to go to a different Explorer or go to the online experience. So you can kind of just do that right here. So let's make some more changes to this code. Now, one of the things you'll notice here is this is sample code. It doesn't have exception handling. It doesn't do sort of the right set of things that you would do in production code. So I'm going to go and make a little change and show you exception handling, in particular, how it relates to monitoring and what you can do later with DevOps. So I'm going to comment out this upload from file async and replace it with this fragment of code, and we'll go through what this code does. Okay. So I still have the upload from file async. I've just wrapped it in a try catch, and I'm catching the exception. So at the very least, I should do that. And I'm printing out a couple of things here. The exception gives me an HTTP error and an error code, friendly error code. gives me what time it happened, and it gives me a server request ID, which is a unique ID assigned to your transaction by the Azure Storage Service, and a client request ID that I actually get to specify during my request. So that's the other thing I've done here, is I've overridden the client request ID. By default, the storage client library gives your client requests a GUID. The reason you'd want to change this, and not necessarily to a static string, but the reason you typically want to change this is what constitutes a request for your service might have multiple services that it talks to in Azure, might have multiple calls to Azure Storage, and you want to tie all those together and be able to correlate them. So doing something like this will allow you to correlate this. So let's go ahead and run this again. And now I see that I have an exception that I was just swallowing earlier. And that exception is that the specified blob already exists. Remember, I commented the delete blob. So now when I'm trying to upload the blob again, the service is saying, hey, you can't upload it because that blob already exists. And that's the exception I get back. And here is the client request ID that I got returned, the same client request ID I sent in. And this server request ID is something that I can kind of copy out and take and look at in the monitoring piece later. So let me go ahead and do that really quickly. I just paste that in here and come back to it later. So that's kind of the blob service and getting started samples. I hope this kind of shows you that it's very easy to kind of just dive in and start looking at it and then start exploring the different APIs that we have and that you can code against, whether it be .NET or Java or what have you. We have samples in many of the client library languages, and that's something that you can go and use. The other thing that I would like to point out is all of the source code for all of our client libraries is open sourced. It's on GitHub. So if you're ever curious about how are these guys wrapping the REST API calls, what are they doing around retries, exception handling, whatnot, the source code is on GitHub for every single one of our storage client libraries and always will be. So you can go ahead and look at that. If you need to make a fork of it to add some changes of your own into the client libraries, you certainly can. So let's switch back to our slide deck. So we talked about blobs. The next thing we'd want to talk about is tables. So tables are our NoSQL store. Essentially, they're a schema-less key value store. So the first thing to note there is you're not necessarily putting in structured tables. It could be semi-structured tables where every row in your table can have a different schema. There's no limits on the number of table rows or the table size in Azure Storage, and that's really the huge benefit you get out of it is you can have a table that is hundreds of terabytes in size. It's only limited by the size of the storage account, which is half a petabyte. And we do have tables like that. Xbox and Skype are good examples. Their tables run into the hundreds of terabytes and indeed into the petabytes, and they shard their tables across multiple storage accounts. The other big thing that we do for you is dynamic load balancing. So rather than having to worry about which portions of my table are getting load, how do I scale these out? We actually watch the read and write patterns on your table storage, just like we do on blobs and queues, and scale. So by that we mean that, let's say a certain region of your table is getting heavily read over and over again. We'll start serving that portion of the table off of their own set of servers, essentially. So we'll scale this out. And the way you kind of help us out here is you give us these hints. We have two indices called partition key and row key. Provided you've designed and chosen your partition key well, you can get nearly infinite scale from our storage service without having to worry about saying, oh, should I be monitoring for load? Should I be splitting the partitions or anything? We take care of that. The trade-off is that it's really optimized for key value lookups. So what Azure Storage Tables does not give you is rich indexing. It does not give you rich query capability. If you want something like that, you probably want one of the other services, either a document store, a JSON document store like DocumentDB, or go the full managed route and relational route and go to Azure SQL DB. What you get, what those services don't give you is the massive scale and cost efficiency of Azure Tables. So that's the trade-off you've got to look at. The other interesting thing that we have here which does come up often, is do you guys do atomic batches? And we do. So we have this notion of entity group transactions where you can, within a single partition key, you can batch up to 100 entities, and you can actually get an atomic commit or not on that group of entities. So let's take a quick look again at the code for tables. I'm not going to pull up the sample and everything. I'm just going to load a pre-done sample here, or preloaded sample to save some time. And what I'm looking at here again is sample operations with basic tables and advanced table operations. But I've also added a couple of lines of code here, and I want to kind of talk about that. One of the things that .NET does is the default connection limit when you start is 2, which if you're trying to do highly parallelized lots of operations, doesn't really work. You'll actually just get bottlenecked on the client. So what we recommend is kind of changing this up to something much higher. The other thing we've done here is disable, and this is system.NET, Service Point Manager. The other thing we've done is disable using the Naggle algorithm. Naggle is an algorithm that batches small packets or small requests on the client before sending them off, and essentially inserts a delay into those packets. If you're doing small operations like small entities or queue messages, you want to turn this off so you get the throughput that your VM or your code can actually support. So we've done that, and let's go ahead and actually run this sample. And what I'm doing here is just creating some entities and creating them in batches in this case. And this is this entity we are just creating and working with. It's the sample. So let's go ahead and exit that. And look at what we're doing here. Okay. So the first thing we do is create the table, similar to creating the container. And what we do here is have this notion of a customer entity. And let's go look at the definition for that. That's your entity. And that inherits from table entity, right? So you can look at the table entity, and that is actually something that we provide. And these are the partition keys and the row keys that I talked about, right? So that's kind of the thing that you can use to design your table storage. Okay, so back to here. I can, again, just like with blob storage, insert or merge. And insert or merge is upsert, essentially. If the entity exists, update it, otherwise insert it. I can retrieve using a single point query, and I can delete. So again, very, very simple hierarchy to use. All right? Okay. So let's go back and look at the last piece for developers, which is queues, and then we'll move to the pieces for you as an IT professional, which are disks and files. So queues are essentially reliable messaging at scale for cloud services. So you're not going to use Azure storage in isolation. You're going to typically have some other service, whether it be a web service, whether it be a worker roles, or what have you. Queues allow you to decouple all of these components of the services that you're building and scale them independently. And do it in a way that it's resilient to crashes in either your front ends or your workers. So queues basically give you simple queue semantics, put, get, peek, and update messages. There's, again, no limits on the number of queues and messages. You can have 2,000 queue messages per second on a single queue, and you can have up to 20,000 total queue messages per storage account. Two kind of unique features that we offer are message visibility timeout and update message. So message visibility timeout is really useful for when you on-queue a message, you essentially give it a timeout that the service should make the queue message visible again if the dequeuer doesn't return in that time. Right? So that's interesting. Why would you do that? If you have a worker role that crashes while processing a message, that message will eventually become visible in the queue for a new worker to dequeue it. So you now don't have to worry about your worker role crashing or not crashing. You know that that message will definitely get processed, right? And then you can come back in and also call update message. If you have a very, very long workflow that you're trying to execute, you can checkpoint progress using update message. So let's say you crash at step 45 of 60. Your next guy that comes in dequeues it can start at step 46 because it has the checkpointed state in that message. So those are two features that are commonly overlooked, but those are very, very powerful and flexible and make it easy to use queues with your services. Let's again do a very quick demo here with queues. All right, let's run that. And again, just inserting some queue messages, inserting them in a batch, and dequeuing them in a batch. Same kind of semantic, right? Programming semantic is almost exactly the same. If you look at queue operations, you have an add message, a peak message, dequeue, and you can have a delete message, and you can have update, right? So pretty straightforward. I'm not going to kind of spend a lot of time here. It's easy to kind of go look at. So these are sort of the three building blocks. If you're a developer writing code against Azure Storage, you would use these three building blocks and build your PaaS services, right? This is sort of an eye chart, but I show it to kind of give you the sense of there's a very definite hierarchy here and very consistent programming model for all of these. These are just some of the key APIs that are in your REST API and client library documentation. The slide deck is posted, of course, so you can use this as a reference. So now let's switch gears and look at disks and files, which are much more relevant if you're running your own infrastructure and you have infrastructure as a service VMs. So Azure Storage disks are essentially persistent disks for your IaaS VMs. If you're running an IaaS VM today, if you've booted one up on Azure, you're using Azure disks, right, under the covers. The operating system disk is persisted to Azure Storage, and any data disks that you add are also persisted to Azure Storage. As we talked about earlier, the disks are backed by page blobs, so they're really using the same API. They're using the same REST API under the covers. When the VM comes down and talks to the hypervisor, there's a driver there that's doing that translation to all the REST calls. The nice things you get out of Azure disks as a consumer is you get 3 strongly consistent synchronous copies on every write. So when the write completes inside your VM, you know that you've gotten 3 copies on our system. So you typically don't have to worry about things like building RAID redundant disks inside your VMs. You might still stripe disks for performance, but you're generally not needing to stripe disks for reliability because you know we've kind of replicated it for you and we do all of that work for you. And if you're looking at scale-up workloads, we have a new offering that GA'd just a couple weeks ago. They're called premium storage disks. Our normal disks are backed by hard drives and are sort of magnetic hard drive backed and give you the latency profile and IOPS profile that you'd expect there in terms of allowing up to 16 terabyte disks, up to 500 terabytes per disk. So you can have about 8,000 IOPS on a single Azure data disk. With premium storage disks, you can go much, much higher. We built premium storage disks for high-performance I/O-intensive workloads like SQL, like Exchange, SharePoint, Dynamics. We've worked very closely with these teams inside Microsoft as well as teams outside Microsoft, whether it's Cloudera, DataStax, Mongo, Cassandra, to look at their workloads running on top of Azure Premium Storage and say, do we give you the performance that you need to run these workloads at scale on our cloud? You still have 3 strongly consistent writes here, which is really nice. We're writing to 3 SSDs behind the scenes, so you again don't have to worry about redundancy and protecting against data loss there. You can get up to 64,000 IOPS per VM here and about 32 terabytes of disk space. And because we're kind of provisioning space for you on our cluster and guaranteeing performance, you buy it in a slightly different way. Page blobs, you kind of pay by the byte. Here, you buy in chunks of disks, right? So you're essentially buying a 128 gigabyte disk with 500 IOPS, all the way up to a terabyte disk with 5,000 IOPS. And you can also stripe these. So let's go look at one of these VMs that I've set up for us to look at. And we'll run some performance numbers, even though they're sort of synthetic workloads, if you will. Let's go and look at them and see what kind of performance we can generate. So this is a VM running up in Azure. It's a premium storage VM. There's a new class of VMs on Azure called DS series VMs, and you'll have to allocate one of those to use premium storage. So I have my C drive, which is an OS disk, which is back to storage. I have D drive, which is my local SSD that doesn't persist across reboots. And then I have two persistent disks here that are SSD backed to premium storage. One is a single terabyte P30 disk, and the other one is 10 striped disks for 10 terabytes total. If you look at storage spaces, they're kind of set up the normal way you would set up disks. You would attach disks, they'd show up as disks here, and you could set up storage pools. And they're named in this funny way because I want to show you two workloads here. I'm going to run a tool called Iometer that essentially simulates load on those disks and does so at a high enough rate to show you the performance. And I'm going to split this into two things. The first thing I'm going to show you is when we talk about high IOPS for writes, we can run a workload that is all writes. Right? So this is essentially running against the G drive, the 10 terabyte drive. I have a pretty high queue depth here, so I can generate enough load. And I'm going to go ahead and start this run. And kind of right away, you can see 50,000 IOPS, consistently delivered to you, right? And we can kind of view this in a little more friendly way. And you can see that it's generating that very, very consistently. There's not a lot of late variance there. You're getting those high IOPS. Because we have a little bit higher queue depth, your latency is a little bit lower, but if your queue depth was lower, your latency would be better as well in the single-digit milliseconds. And despite a queue depth of 128, I'm still doing under 10 millisecond writes. So that's kind of my write scenario. What's kind of cool, though, about Azure Storage is we give you a read cache on the VM itself that caches all your read data. So no workload is purely writes. It's a mix of reads and writes. And frankly, many of the workloads, like SQL, are heavier read than write. It varies, of course. What we do there is we maintain a read cache from that local SSD on the machine, and we then give you sub-millisecond reads off of that cache, and we don't count it against your IOPS limits for your scalability. So I'm going to stop this and start the reads. And the thing I want you to notice here is I'm running against that cache reach, which is a single P30 disk. I'm doing 100% reads here. So let me go ahead and start that run. And I'm getting 64,000 IOPS here for reads, right? Very, very useful. If you have a heavy workload on writes and reads, you can still get the benefit of using that 50 to 60,000 IOPS for your writes and get all the benefits of having that read cache serve you all your reads much, much faster and without counting against your IOPS limits, right? Latency here, as you can see with the cache, again, I have a very high queue depth, so I have 1.5 milliseconds here. In fact, if I stop this and change my queue depth here, or change it down to 16 is fine, I can see that my read latencies are in the 1 millisecond, sub 1 millisecond range typically. Right? So that's kind of the thing to think about when you're deploying IaaS VMs is think about how you're going to lay out your disks, how you're going to, for SQL, for example, you're going to have a disk for log writes. Most likely, you're going to have a disk with your databases that's larger and striped and can do all your reads off of there. You're going to use read caching on that. So it's kind of it's a design problem that you have to go in as you provision these VMs for those scale-up workloads. Let me switch back here. Go ahead and stop this workload. So we have a session on Thursday that's purely devoted to premium storage and all the design trade-offs and how you would go looking at this. They'd also talk about a little bit of the internals there, how it was built. So definitely recommend attending that if you're interested in premium storage and bringing those kinds of VMs with very, very high scale up and running. So disks are direct attached storage, right? They're essentially iSCSI targets that show up. You attach them to a single VM. You now have to worry about the VM reliability, right? Is the VM up or down? if I'm trying to share out the data on there, it's not exactly ideal. You have to kind of look at how do I provide a very reliable shared file storage. That's the reason we have Azure Files. And Azure Files give you SMB access to Azure storage without requiring you to run a VM to host that storage. Right? You don't have to, normally when you share out a share, like you give somebody a share and say, hey, you can net use to this share, there's an attached machine behind it that actually is exposing that as a share. With Azure Storage Files, we provide that share, we provide that service, again, with all the reliability, with all the data durability, the availability of the service that we've been talking about so far. But the nice thing then is you can net use to this. It's natively supported by both Windows and Linux. It uses the SMB 2.1 protocol. You can just create a net use share and use it. Your applications are none the wiser that they're using Azure Storage. So if you have a legacy workload that you want to bring in to Azure and without rewriting all that code, or you have you can't rewrite that code, this is a good way to still leverage Azure Storage, use your VMs, and have your workloads running. Right? Again, there's no limits on the number of shares. There is a limit per share. You can have up to a 5 terabyte share, up to 1,000 IOPS per share, and then you can add as many shares as you need. Those are limits that we are working on. The service is currently in preview, and we'll be GAing it soon. So let's go do a quick demo again. Go ahead. If you don't mind holding questions till the end, we'll have plenty of time. Thank you. So let's look at this. So I have 2 more VMs here that I'm going to go ahead and net use on. So the first thing I'm going to do actually, of course it signed me out, is go to the portal and create a file share there. Okay. All right, and I'm going to switch over to my MSDN account. Okay. So this is the new Azure portal. If you haven't seen it, I'm sure you have. Here are my storage accounts, and here are my VMs. I'm going to click on that Demos 15 storage account that I've been using all along. And then I have some things here that I can click on and kind of browse the hierarchy as well. I'm going to click on File Shares. These are a little rudimentary right now as we build out the portal. They will get much more full-featured over time. You can see that I already have a share here, but I'm going to create another one. Right? I'm going to call it Ignite. And I'm going to go ahead and click OK. And it said, OK, I've created that new file share for you. Right? So that's all I've had to do here. And going back to my VMs, I'm going to go ahead and net use to that share. And let me show you what I'm doing here. So it's a typical net use. I'm saying net use to some drive. Here's the share name I just created, Ignite, on the Demos 15 account. And I give it the username, which is the same as the account name, and my storage key. And I go ahead and let me actually map this to Z drive, because I think I am using D drive already. OK, so I've just net used to that share. Didn't do anything. It's a typical net use command. And here's that Ignite folder share. Right? Looks pretty much like a file share. I can actually go look at the capacity. That's not what I want. It's 5 terabytes, right? And I can go in here and create a new folder. I can create a document if I want. Okay. So let's go to another VM and kind of do the same thing. I'm just going to copy that net use command out of here. And I've got the same share now on a different VM. And you'll notice that that file is here, just like you would expect on a share. So I can go ahead and make a modification here. And I'll go back to my first share, and that share reflects the changes. So exactly what you'd expect if you're using a share on-prem today. Looks and smells the same, except it's backed by Azure Storage, right? The really neat thing is I can also get to this from Linux. So this is a machine that I have running Ubuntu and has the CIFS packages installed. I'm going to mount a share here, and I'm going to mount the same share. So I'm going to mount the Ignite share onto this drive, onto this mount point. Okay. And if that is working, it's going to ask me the credentials, which I'm going to give it. Okay. So at this point, it's mounted it. So I can see CD to Ignite, ls in there. There's the testing folder that I created, and I can look at the same file on Linux, right? So this is the nice thing is you can kind of go back and forth. If you have a mixed operating system workload, you can have a single shared disk that is available across everywhere. All right. So let's, what are the canonical uses beyond sort of file sharing, if you will, and bringing your legacy apps? Actually, it turns out it's pretty useful for doing things like dev workloads too, having a set of tools and things that you can portably, or debugging tools and whatnot, that you can map to any share that you need. Because we offer REST upload to files from your on-prem, you can also use it for things like config distribution, config file distribution. We've seen some customers do that where their VMs in Azure have these mapped as net use shares with File System Watcher or something running on them to watch for file changes, and they upload a new config or something from their on-premises, and it works well for that as well. Okay. Sounds good. So, and just to kind of summarize what the virtual machine architecture looks like, when you bring up a virtual machine, you always have an OS disk and you have a temporary disk. You now know that that OS disk has a disk cache, actually, in the way, and talks to Azure page blobs. All your standard data disks also talk to Azure page blobs. If you have premium data disks, they talk to Azure page blobs as well, just on a different set of hardware with SSD storage. And we've talked about that SSD read cache that gives you fantastic read performance. And you can now have SMB shares that you can map onto the same virtual machine, which goes to Azure Files. All three of these abstractions are on Azure Storage. So that's kind of the way to think about this when you're designing and bringing up your VMs is what mixture of these things do I want to use? On a DS VM, by the way, you can mix and match premium storage and standard storage. So if you have certain data workloads that require very fast disks, but then you have a lot of data that is fine on a slower disk, you can actually mount a mixture of standard disks and data disks as different drives based on what you need. So that's something else that you can combine as well. So this kind of concludes our overview of our Azure Storage data abstractions. Now, there are other Azure Storage services under the Azure umbrella. I want to just call them out briefly and show you where they fit in here. Azure Data Lake is something that was announced at Build last week, and a preview will be coming soon. If you have HDFS workloads, if you have something in the Hadoop ecosystem where you want to pull in large volumes of data and then run data analytics on them, you want to look at Data Lake. Data Lake is a service running on top of Azure Storage. It writes to the same block blobs, but they do all the hard work of sharding for high performance across storage accounts and removing the file limits. They have AD-based ACLing, so you can do things like create a 1 petabyte file on Azure Data Lake and then run your analytics over it with any open Hadoop tool that talks to HDFS file systems. So that's something to look forward to if you're in that space. DocumentDB is a service that's in GA today. It's the analog of tables in a way, but it gives you a JSON document store. So think of it as MongoDB as a service. So we, of course, support Mongo Labs running on top of Azure Infrastructure as a Service VMs. But if you want a managed service, you can look at DocumentDB. SQLDB is managed SQL. You can get pretty high performance relational SQL databases. Again, with all of the geo-replication, mirroring, failover, point-in-time recovery, all of that being fully managed for you. And Service Bus, lastly, is kind of analogous to queues. If you look at queues and say, well, I really want things like PubSub, or I want things like guaranteed in-order message delivery, Service Bus is more an enterprise messaging service, whereas queues is more about a high-scale queue service. Okay? I want to kind of switch gears here and talk a little bit about the Azure storage architecture. We've kind of been alluding to this all along, but all of the abstractions that we talked about run on top of one single massive distributed file system, right? And on top of that distributed file system where all the disks are is a scale-out and load balancing layer that does that dynamic load balancing, the watching for load and figuring out where things need to go, okay? The reason we show this is kind of it gives you two things. One, it gives you that nice, consistent programmability model because it is the same service, it is the same code. Everything looks nice and consistent. But it also allows us to give you economies of scale by mixing cold workloads like files with hot workloads like disks or tables, right? So we're able to take that, have everything running on a single consistent platform, and give you those economies of scale in terms of consistency and cost. It also allows us to give you all of these capabilities of Azure Storage across all of those data abstractions. So when we talk about scalability, we've said this before, 500 terabytes of data per account. You can have as many accounts as you want as a customer. You can do 20,000 transactions per second per account. And you can do as much as 10 gigabits per second ingress and 20 gigabits per second egress even with our geo-replicated storage. It's actually higher, 20 and 30, if you're using locally redundant storage. We have those durability options. Locally redundant storage is the 3 strongly consistent copies in one data center. Zone redundant storage is 3 strongly consistent copies in 3 physical facilities in the same region. And geo-redundant storage is 3 additional copies that we asynchronously geo-replicate for you automatically. Right? So that's a few minutes lag, but we're replicating it for you for disaster recovery in case there's an earthquake or some other kind of natural disaster that completely wipes out a single data center. Your data is still going to be available in another region. We do provide read access to that disaster recovery copy, so you can go verify that your data is indeed getting there. We give you an API that tells you how far behind we are on replication lag. And if you need, there are certain services that can actually use this for their availability, because we can give you an additional 9. We have 3 nines availability for reads and writes, and 4 nines for reads with our AGRS. Okay. So, access control and analytics we'll talk about going forward. We do provide different models of access control, and we have pretty rich analytics on top of our platform. If you're interested in learning a little bit more about the Azure storage architecture and figuring out how to design for scale and performance, we have a session on Friday. That's a 400-level talk that really kind of dives into the architecture of storage. So let's switch gears and start talking about the DevOps piece of this, right? And monitoring production and monitoring in production is key for any workload you run as a service, as a person running a service, right? And you do this for a few different reasons. You do this to make sure your business KPIs are being met. So you are making a promise to your customers with your service. You want to make sure those are being met. You want to find the problems before customers report them so you could proactively fix them. And you want to monitor a bunch of service fundamentals like health, availability, perf, and capacity. There are a few different approaches to this. There's sort of the outside-in approach that you can do with things like Visual Studio App Insights or external tools like Gomez and Keynote that kind of look at your service end-to-end from an outsider's perspective and make sure everything is going okay. We'll focus here on the inside-out perspective, which is what can you do in the services that you're using to make sure everything is running the way you think it is. So the first piece of this that storage provides you is Storage Analytics Metrics. It's essentially the perfmon for Azure Storage. There's more than 40 different metrics that we track for the blobs, tables, and queues. And we give them to you with minute granularity, so you can look at the data across the last minute. We provide automatic retention policies, and the data is stored in your account, so you can download it and do with it what you will. The second piece that we offer are analytics logs, which are the storage equivalent of IIS logs. Every single transaction that you make against storage is actually logged. It includes many of the request characteristics, same granularity, same retention policies, and you would use this more for diagnostics and troubleshooting. You'd start with metrics, see what are places where I have problems, and then dive into logs. So let's take a quick tour through the portal where we can look at this. So the same account that I was showing you, let me go ahead and close this out. Let me zoom in a little bit here. Has some interesting graphs down here that have been running while we've been running our demos. Right? So let's start with this guy. This is the total requests in the last hour. So this is using that minute metric data. And this is showing you off of these three services, blob, table, and queues, how many requests we've made, right, over the last hour. Oh, sorry. So this graph shows you the total requests per hour for the last hour, and you can see with blob, tables, and queues, how many requests I've made, right? And because I'm mostly running samples, it's not that many queue and table transactions, but blobs, I actually have my VMs that I was showing you running on top of this account, which is why you have so many more blob transactions, block blob and page blob transactions. So you can kind of see, there's some interesting periods where there's spikes, but there's also things you can do, like go and look at the latency graph, which is probably much more interesting for you. And this is showing the average server latency and the end-to-end latency for the blob, queue, and table services. End-to-end latency is the time it takes for a transaction to leave your client machine, or client VM in that case, and come back round trip. Server latency is the latency that we, the service, take to return to you once it hits our front ends. So this gives you, comparing these metrics, gives you a nice capability of, at a glance, knowing, is the problem with Azure storage, or is the problem with something between my client and Azure storage? It might be the client itself, might be the network. So you can see here, I have a pretty fast network here. So, oops. You can see that the server latency versus end-to-end latency is not that different, right? Table is the same thing. Table is a little bit more because I do more transactions. But yesterday when I was running this at my hotel, I was getting 15, 20 milliseconds on the server side and 1 to 2 seconds for the end-to-end latency because the Wi-Fi is terrible at the hotel. So that's something you can easily, quickly say, what's happening there and why did it happen? And you can also kind of look at where things spiked for a bit and what happened. But you're usually not going to come in and want to look at these things manually, right? The useful thing that you're probably going to do is once you get one of these charts set up is add an alert, right? You can just go in and say, on this storage account, let me just call this a test alert, and I'm going to use average end-to-end latency and say, hey, if it ever goes above, let's say 2 seconds, go ahead and email me, right? And just like that, I've gone ahead and set up an alert on any of these metrics. And if you can look at the metrics, there's a huge ton of them. So let's look at blob. There's a lot of metrics that you can kind of look at. All of these are documented. But you can look at, for example, are you getting throttled? Are you getting network errors? Are you getting, if you're using shared access signatures, are you getting errors there? What does your total egress look like? So you can really set up a very rich monitoring on top of either your VM disk accounts or your PaaS service accounts, set up alerts against them, and not all of that without really leaving the portal. Okay. All right. So let's go ahead and switch back here. The one thing I do want to show you, though, is that's sort of the, hey, top-down metrics view. What about the logs that I talked about? The logs are actually here. If you go to the Storage Explorer that we were looking at, they actually are in your blobs container, in that $logs folder. And you can kind of go in, browse through them. Here's the logs for today. And you can see that 2100, it's UTC, so roughly 9 o'clock. So between the time that we've been running the demo, the logs are in here, and they're showing up on a minute level. Right? So you can kind of go in. Now, obviously, if you actually download one of these, it's not going to be the most interesting thing. Because it looks like that. Right? You can throw this into any kind of CSV formatter and use it. But we have a tool that we want to I want to quickly show you here called Microsoft Message Analyzer. Okay? It's a tool that you can use for network logs, for other logs, but it works really well. We've worked with them to kind of build in some parsers and analyzers for Azure storage. So here I have, in the interest of time, I'm just going to show you a scenario that I've already loaded with a set of storage logs that I've downloaded from there. And you can see that I have these organized by client request ID. And I can actually start running queries on them. Because this thing understands the structure of those logs, I can do strongly typed queries on them. So like, let's say, excuse me, status code is greater than 299. I'm going to look at greater than 299 because that's where most of my error codes are. So let me go ahead and apply that filter. And I can quickly at a glance see where my issues happened, right? So here is a thing that failed. And if I click on it, I can look at what the failure was. That was a 404 on that request. And you can also look at things like some of the conflicts that we put in. So put blob, this was, again, a 404 that said, hey, couldn't find it. Okay. So this is a good way to kind of look at this. You can run some pretty sophisticated queries. It works pretty well at high scale. And here's an example, actually, of, let me run it, the same query on here. Here's one of the demos. This is something I ran last night. But this is the put blob that we put in with our client request ID that actually failed with a 409 error. Right? So I can kind of go through, load up a bunch of data, download it, load it up, and start looking at it. Okay? We also provide client logs. You can enable for the .NET Client Library, enable .NET tracing, use a standard tracing. With every platform that we provide, we use the appropriate sort of tracing. You can put in the client request IDs there and then really correlate them across, from with Message Analyzer and tools like that, be really able to correlate your client logs, your network logs, and your server logs. Network logs. One thing that's actually pretty useful here, and if we have time, we'll do a short demo with Fiddler, is Fiddler and Wireshark are pretty useful to debug any issues that you're having with your storage when you're developing against it. So it tends to turn off the turn off HTTPS for debugging. That makes it a little bit easier, though you can decode HTTPS traffic as well. And combining that with the tools I've just shown you makes it very, very easy to know what the problems are. And when you have all of these logs together, you can actually correlate them with that client request ID that we've been talking about that gets percolated through the system. Okay. So let's talk a little bit about design patterns and kind of end this talk with what's new and what's coming. So one of the most important things that we receive as feedback from customers is, hey, this is all well and great. We really need to encrypt our data on the way in so we can send you a very secure encrypted stream and not worry about issues. So, however, thus far we have not had an easy way to do this for customers. So we're pleased to announce sort of a client-side encryption library that we're providing that automatically encrypts data prior to sending to storage and automatically decrypts on getting them back. So for the blobs that you looked at today, the full blobs can be encrypted. For tables, you can encrypt entities. You can encrypt regions of tables. You can encrypt those batch transactions. And the same thing for queues. The benefit of us doing the libraries for you is that, and doing this on the client side is we never see your keys or your unencrypted data, right? We just see an encrypted byte stream, which is perfect because that way you as the service provider, the service runner, has all the control over when and where to decrypt. We provide all the we've coded all the proven security practices into our library. We use envelope encryption, key rotation, things like that, support for those things. The encryption that we're building is interoperable across the client library. So as we provide this, if you have a .NET client doing the writes, but a Java client library doing the reads, this encryption will be interoperable across them. And the source code for all the encryption client libraries is also available on GitHub for you to go and look at and make sure that you can trust us there. The code is very, very simple. I'm not going to go into the demo here, but essentially, we have the upload API here. We do a little bit of a wrapper around it. We have a blob encryption policy with a key. We add that policy to the blob request operations, and then we go ahead and upload it, and the encryption happens for you under the covers. Same thing for download. As long as you have this encryption policy and the key provided, we can do this for you. The next question comes around, hey, okay, that's great. Where should I put my keys? How do I manage my keys? Key management is a huge issue. Azure has a service called the Key Vault service. We are integrating with the Key Vault service in such a way that you can put your keys securely in Key Vault. Key Vault is essentially a hardware HSM as a service. And we never see the keys again. So there's some interchange between the client library and the Key Vault service such that you can store and manage your keys in Key Vault and still use the client-side encryption. Okay? So that's sort of encryption. The other thing that comes up commonly is access control. You don't usually, all my demos so far, I've been using that storage key, which is my password for my account. I'm going to go after this meeting, after this talk, and rotate those keys. Otherwise, you have access to that account. That's not ideal at all. We also showed you the public access, but you need something in the middle. And what we have there is called shared access signatures. It's delegated authorization, essentially. So you can isolate resources and put permissions on them. So for example, you can isolate a container, blob, queue, a table, or a region of a table, and set read, write, or delete permissions and give me some combination of those. You can set a time period in which I can access that resource that you grant to me. And all of this can be done with this kind of URI that we call a shared access signature. If you look at it, it's essentially looks like the account stuff that I've been showing you, except it has these other query parameters. And this signature is signed with the key. That can be done offline. There can essentially be a token issuer that issues this token to an untrusted client and says, use this to talk to Azure Storage. You'll get access, but only scope to the things that I allow you to get access to. Other things that we allow access to, you have, of course, read, write, delete, time. We're adding IP address ACLing. So you can say, here's my whitelist or here's my IP address range. Nothing other than this should be allowed to touch the storage account. We have protocol as well, so you can completely disallow HTTP access, which is good if you don't want somebody insecurely sending you things over the wire. And lastly, we're adding in account-level shared access signature. So far, we've always been able to do it at entities below the account, like containers, tables, and queues. With the account shared access signature, you can really protect your entire account with a shared access signature and then never have to use your keys again. So you, the service administrator, can own the keys and give out a shared access signature to the developer. And then in your code and everything else, it's only the shared access signature that gets used. That's a pretty useful thing that's coming very soon as well. And where this becomes really interesting is anytime you have large-scale sort of upload-download scenarios where you don't want to build a large proxy service. We already provide you this huge scale. Why would you want to go build a proxy service just for authentication? You can essentially, and forwarding the data through your service, you can authenticate with your users issue them a SaaS token, and let the storage service handle the burden of reading data in from them or writing data out to them, right? That's the big, big benefit. For any mobile IoT scenarios, we have customers with millions of devices that read and write from Azure Storage directly rather than going through their proxy services. You can do this with, we have core support, so any kind of web and JavaScript coding as well that allows the browser to come directly to storage as well. And of course, for in big data and certain industries like financial services, whatnot, shared access signatures allows you to build write once, read many storage with the access and the ACLs there. The last pattern the third pattern I want to touch on is large-scale append. This is another common ask that has come up to us for a little while. We're adding a new blob type called append blob that allows you to do multi-writer appends to a single file. This is very useful for things like logging. It's also useful for services like the data lake service, which is whom we built this for, and now we're exposing it to everybody. It's really optimized for that large-scale, multiple append scenario. You don't have to do this, synchronization across clients that you needed to do with block blobs. The API, again, very consistent with the block blob API. As you can see here, all I've done is I get an append blob reference, and I append blocks, right? So otherwise, the coding, you're not changing more than a couple lines of code there. And you can, of course, use this with shared access signatures. The last pattern I want to talk about is high availability apps. We talked a little bit about RAGRS and the fact that it gives you 4 nines on reads. However, you actually need to change your code a little bit to support this, right? Your client has to support a read-only mode because it's a read access GRS. You can't write to that other account. We help you out here by having the client libraries provide retry policies. So the default back-off policy is exponential, but then you can specify on failure, should I go to the secondary automatically? It's just an enum you can change in the client library. You can say primary, then secondary, or secondary only. And the retry operation is stateless, right? So the interesting thing here is when you go down this path, what you want to do is have a short circuit pattern. And what I mean by that is, let's say the storage account goes down for 4 or 5 minutes for some reason. You don't want to have long timeouts every time the primary being tried and then only then switching over to the secondary. So what you can do is a simple short circuit pattern that we enable in the client library, where you can say, hey, if the primary fails for a couple of times, let me just switch to the secondary for a couple minutes, then I'll try the primary. If the primary comes back, I'll switch my circuit breaker back over, right? And the way we support it is this retrying. You can have an event handler that says, every time there's a retry in the client library, send me a callback, please. And you can keep, this is a simple thing that says if the retries exceed some threshold, go ahead and switch to the secondary only, right? Just go start talking to the secondary. And then you can get back, another event handler that says on every, response, check whether I read, the secondary, and every few minutes or so, try the primary again and see if it's available. So this is a pretty useful pattern in terms of saying if your app supports read-only mode, you can switch the circuit breaker over, do your things, and come back, right? That's kind of a thing. I don't have time to go over the demo for this, but we have samples up there that implement this pattern. So I want to kind of start wrapping this up and summarize. In terms of announcements, just to kind of give it to you in one slide. Premium storage, GA 2 weeks ago. It's usable now, so any high-scale, high IOPS workloads, you can go try that today. The C++ client library is also GA, so if you have native code that you need to run against Azure Storage, you can go do that. Azure Files now has technical support available, so if you have scenarios that require your file shares, you can start using that. You can call tech support, and this is kind of getting ready for GA effectively. The new Resource Manager, you've probably heard about the Azure Resource Manager. Storage accounts support that. We talked about client-side encryption. We mentioned that there's a Xamarin library, so if you're doing mobile development, that might be interesting to go look at. We talked a little bit about append blob and the SaaS improvements. An iOS library is coming if you want to use storage there. And the Azure Import-Export service that we didn't touch on much, but allows you to ship data to Azure via disks, essentially, if you want to import or export in bulk, is expanding to other regions as well. We have a couple more sessions here at Ignite. The one on Thursday is a premium storage deep dive, and then the one on Friday is really more detail on the storage architecture and how to design for high performance. We're at the Expo Hall through the end of day Thursday. Please stop by and meet us if you have any questions. We also, I leave my laptop up here. If you want to come and talk to us about specific scenarios or specific issues that you're having problems with, or you just want to learn more about one aspect of it, you can sign up for a 30-minute slot. Come on by the Expo Hall anytime this week, and one of us, we can break off one-on-one and go into your specific questions or specific scenario. So again, thank you for taking the time to stay here. I'll leave you with some documentation links and the Azure Storage blog. We are very good about monitoring the MSDN forums and the Stack Overflow. So if you start writing code against our platform or using our VMs and you have questions, please post them there, and the engineering team looks at them every single day. So I'll stop at that. Don't forget to fill out the survey feedback, please. We do take a look at this very carefully as well. Especially verbatim comments are very useful in figuring out what we can and should do better next time. So I'll stop there, and thank you again, and I'll be here for questions.